The single responsibility principle, S.L.P, states that a class should have only one reason to change, meaning it should be responsible for just one specific task. In many apps, the login module is a perfect example to apply this principle. A poorly designed bad login manager often violates SRP by handling multiple concerns, such as validating input, making API calls, and storing user data, all within a single method. To follow SRP properly, each of these responsibilities should be split into separate components: an email validator for input validation, a login service for handling authentication requests, and a login manager for coordinating the overall login process. This separation makes the codebase more modular, easier to maintain, and simpler to test. The open-closed principle, OCP, states that software entities like classes, modules, and functions should be open for extension but closed for modification. A bad login manager typically violates this principle because it needs to be modified every time a new authentication method, like Google, Facebook, or biometrics, is introduced. Instead, by defining an authentication strategy protocol, each authentication type, email auth, Facebook auth, biometric auth, can adopt the protocol and implement its own logic. This way, the login manager remains closed for modification. It doesn't change when new strategies are added, but remains open for extension by simply injecting new strategy implementations. This makes the system more maintainable, flexible, and scalable. The Liskov substitution principle, LSP, states that objects of a superclass or interface should be replaceable with objects of its subclasses without affecting the correctness of the program. In the context of a login module, classes that conform to the authentication strategy protocol should behave consistently and predictably. Well-designed authentication types like email auth, Facebook auth, or biometric auth all follow LSP because they respect the contract defined by the protocol and can be used interchangeably without breaking the client code. However, a poorly implemented class like broken auth may conform to authentication strategy but violate LSP by not behaving as expected. For example, if it crashes instead of returning a proper result, it breaks the program's logic and violates the contract promised by the protocol. This not only disrupts the flow but also defeats the purpose of polymorphism and clean architecture. The interface segregation principle, +I, states that a class should not be forced to implement interfaces it does not use. In a typical login module, violating this principle often means having a large, all-in-one subscriber protocol that includes methods for email login, social login, biometric authentication, and two-factor verification. This forces implementing classes to provide unnecessary or irrelevant functionality. A better approach is to split the interface into smaller, more specific protocols, such as email auth service, social auth service, and biometric auth service, so that each class only implements what it actually needs. This leads to a more modular, maintainable design that aligns with ISP, reduces code bloat, and makes the system easier to extend or test. The dependency inversion principle, DIP, states that high-level modules should not depend on low-level modules. Both should depend on abstractions. Additionally, abstractions should not depend on details. Details should depend on abstractions. In the context of a login module, this means that low-level implementations like network auth service, mock auth service, or biometric auth service should all conform to a common abstraction such as an authentication service protocol. Similarly, the high-level login manager should depend on this protocol, not on any specific implementation. This allows the login flow to remain flexible and testable, as different authentication strategies can be injected without modifying the high-level logic.